Alright, so today we're going to be filling in page 103 with volume formulas. There's a little bit more than just formulas. I need to explain some of the parts of those formulas to you so that you know where they're coming from. Okay? Our objective is to apply and identify parts of volume formulas. Okay, so formulas for volume. The first thing we have is a prism. And that's a 2D shape that is stretched vertically. Okay, and the volume of a prism is always the volume of, or the area of the base times the height. B equals the area of the base. So what does this mean? So you could have a triangular prism. Okay, where you'd find this area and then multiply it times the height where it's being stretched out. So this would be area of the base times the height of the base times the height of the whole prism. Okay, you might have like a rectangular prism. Okay, something like that, and it's a pretty terrible drawing, but you get the idea. I could probably do a better one. Hold on. There we go. So you do, the volume would be the area of the base, so length and width. That's my area of the base, times the height of the prism. Okay. So prisms are pretty straightforward. It's the area of the base times the height. So I find the shape that is the base, and then the part that it's stretched along, that's the height. Okay, the next thing we need to talk about is a cylinder. And a cylinder is a special type of prism. A cylinder is a special type of prism. It's a prism with a circular base. Prism, not prison. Okay, so the volume of a cylinder is the area of the base, which is a circle, times the height. All right, now things get a little bit more crazy. The next thing we have is a sphere. And that's like a ball, right? Okay. The volume of a sphere is 1/3 pi r squared, or pi, excuse me, it's 4/3, God. 4/3 pi r cubed. That's what a sphere is. You just have to know it. Okay. The next two are a little bit crazy. Okay. So the volume of a cone, and a cone you can think of as literally an ice cream cone. Okay. And there's a couple of different parts to a cone that we have to talk about. So a cone we can think of literally as an ice cream cone. And the volume of a cone is pi r squared times the height, all divided by 3. Okay, so when I think of this, when I think of a cone, right, I'm trying to draw this as best as I can. we have the height, which goes from the tippy top to the center on the bottom. That would be the height. But there's another height. This height along the edge, this is called the slant height. And sometimes they'll give you information about the slant height. And what you can do is the slant height forms a right triangle with the height, the actual height on the inside of the cone, and the radius, which is this line down here. Okay? So if I draw it big enough, maybe we can see it a little bit better. Okay? And here's that right triangle right in there. Okay, so sometimes they give you information about the slant height and the radius, and you have to find the actual height. So there's some Pythagorean theorem in there. Maybe they'll give you the angle that this is at, and you have to use some trig to find the height, but they can talk to you about the slant height as well. The last thing we have to talk about is a pyramid, a rectangular pyramid. So a rectangular pyramid starts with a rectangular base. Okay. And most of the pyramids that you're going to see are going to be rectangular. You won't see too many other ones, I hope. Okay. Give this a capital L. All right, so the formula for a pyramid also involves that 1/3 that we saw in the cone, and it's going to be 1/3 of the length times the width times the height divided by 3. Okay, so again, they could end up giving you slant height, which is the length as if you were to start at the top and slide down the edge, and that would make a right angle, or make a right triangle, if you used half of the length. Okay, so the slant height they might give you, and 1/2 of L. Okay, they might give you, and you might have to do some trig or some Pythagorean theorem to find the height. That's as complicated as I could think of this is. Okay.